Simon. I'm a PhD student at Orange, which is a French telecommunication company, as well as Inria in Lille. And together with David, Adrien, Eric, Samuel, and Romain, we wrote this paper about the BoaviztAPI tool, which is a tool that was developed in the context of Boavizta, which is an organization which I'm going to talk about a bit in the end. And this tool is used to assess the environmental impact of cloud services using a bottom-up approach. And we truly would like to thank the organizer to allow us to present remotely. And if you have any question, I will be on the Slack, or you can contact me any way you want. Hey, hello everyone, I'm Thibault Simon. I'm a PhD student at Orange Innovation, which is a French telecommunication company, as well in Inria in Lille, and also a member of Boavizta, which is a French organization. And it's in the context of Boavizta that we wrote this paper with David, Adrien, Eric, Samuel, and Romain about BoaviztAPI, which is a tool that we have developed in order to assess the environmental impact of cloud services using a bottom-up approach. Now, a little bit of context that you probably know. This is what we should do in terms of carbon footprint as worldwide, basically all industries, and this is what the ICT industry is projected to be doing. So we have a problem that we should tackle, but to tackle this problem we have to have data about this impact. Now, we know about the carbon footprint of ICT, but we tend to forget the other impact categories that ICT has ramifications on. Notably here, mineral footprint, which is a problem not only from an environmental footprint viewpoint, but also sometimes, sadly, from an ethical perspective. ICT obviously have impacts on water, biodiversity, etc., but we don't have the time to go deeper in that, and it's not really the subject of our paper. But what is more the subject is that when we conduct assessments of the footprint of ICT devices or ICT softwares, we often only consider the carbon emissions, and we also often consider only the energy consumption of such a system, which is not enough because the embodied emission, which are we call embodied emissions, the emissions that come from the life cycle of hardware. Basically, the impact of manufacturing, the impact of material extraction, the impact of distribution, and ideally the impact of their end of life. And what we often tend to do is only considering the energy consumption, which is not enough, especially in France, where this energy is low carbon, yeah. Now, another issue that we want to tackle in this paper is that when we conduct assessments of software, for example, of the carbon footprint of our virtual machines or our cloud usage, the issue that we have is that the tools that are proposed by the cloud providers differ in methodologies and scope that is accounted for, which make the results not comparable between each other, because it's like comparing apple and oranges, basically. So, yeah. You can find more detail on this in the paper, which I definitely encourage you to read about the different scope taken consideratory by cloud providers. But it is in this context that we propose BoaviztAPI. Basically, what we wanted to do is not only consider carbon emissions, so we offer the impact across three impact categories: carbon, obviously, primary energy, as well as abiotic resources depletion, which is metals and minerals, basically, in our context. Now, we wanted to model the impact of cloud instance, basically virtual machines or containers as a service, etc., etc. But we wanted to design a methodology that is open and relying on open data. And to do so, we chose to develop, to use a bottom-up approach, which is basically, in order to model cloud instances which are at the very top, we start from the very bottom, which are the components that are within servers. Now we've talked about the embodied impact, which will be accounted for. So what we do is that basically for each component in the server, we model its embodied impact. Here it's the formula for a CPU, for example. We use the die size of a CPU in millimeter, square millimeter, and we provide a factor for this, an impact factor across the three categories, which basically gives you an impact per square millimeter. It's explained more in detail in the paper, but what you have to remember is that basically here we also divide by the time in order to assess the embodied impact associated with an hour of usage, which is basically my CPU will last for 5 years. So how do I divide this impact to obtain only for 1 hour? Now we also model the usage. Here it's a simple linear regression. You can also find more detail in the paper, but basically for each of the components, which are basically CPU, memory, disk, and some I probably forgot here, but we model as well the embodied and the usage footprint. Now, going one step above, we model the impact of a server easily by summing the impact associated with each component, CPU, RAM, storage, and others, which include PSU, as well as casing, as well as, We also apply the same methodology for the usage. Basically, we add up all the components' energy consumption to obtain the overall consumption of a server. Now, what we want to do is that we add all these servers together to form a cloud platform, but we have to also consider the impact of the technical environment. And you probably know about the PUE, which is used to assess the overhead of this technical environment to make this server run and to cool them. But we also, in our paper and methodology, added like an impact factor to assess the embodied impact of the technical environment, the manufacturing of the data center, which is quite costly. We have developed a little computation to make an allocation based on the energy consumed that you can find in the paper. Now, to know that we have our cloud platform impact, which is constituted of technical environment as well as multiple servers, which are modeled from their components, what we can do is that basically considering the vCPU, for example, we consider what is used by one cloud instance over what is available on the platform. That is, if a platform offers, 100 vCPUs, if your instance use 4 out of these 100 vCPUs, this is how we allocate the impact. And for all the components, which are CPU, RAM, SSD, and the others component, we used this ratio to allocate the impact of the cloud platform to the different cloud instances. Now this is the results that we obtain, which is in CO2 equivalent, but what you can find here is that the bottom-up modeling allows us to separate between the different components and to assess their respective environmental footprint, both on the embodied port or the usage port. And here you can see that the technical environment, which is environment here, is quite costly in terms of carbon emissions, both from a usage perspective, which is kind of obvious with the PUE, but as well as the embodied impact with the factor that I explained earlier. Now, to conclude, basically what we developed is a bottom-up approach in order to find actionable level. As I just show you, basically you can find the impact of each of the components that are modeled. We consider the life cycle of resources, the embodied as well as the usage impact. over 3 categories of impacts which are present in the paper, which are abiotic resource depletion, primary energy and carbon emission. And we do this based on open source data, which you can find in the paper, as well as an open source methodology in order to be criticized, improved, and furthermore compared with other results. Now in the future, we would like to add GPUs, which are kind of the hot topic at the moment, as well as what we call the infrastructure overhead, the infrastructure that is required to do the billing, to do the management of virtual machines, etc., as well as to better handle uncertainties, because in such modelings there are obviously a high level of uncertainties which will be at least quantified the best we can. Now, as I said, we conducted this work with Boavizta, which is a French organization that we are trying to internationalize. You are more than welcome to join us working on these subjects, or you can come and see what you want to do, or come and see what we do. And we cover a lot of part of IT environmental footprint. And it's quite a nice working group if you want to join us. So thank you, and if you have any question, I will be on the Slack, and I will definitely answer you, or by mail, or by whatever means that you want. Do not hesitate to reach me. No, thank you.